This video is for lesson 8-5 about ellipses. On the screen you see a drawing of an ellipse. An ellipse is also called an oval. Now how is an ellipse created? Imagine a string that has ends focused at this point here called F1 and at this point here called F2. And let's say you take a pencil and push it into the string, stretching it outwards as far as you can reach. Then, keeping the string tight, move the pencil along paper. It will draw out an ellipse. Let's look at a GeoGebra animation of this, which makes it a little bit easier to understand an ellipse than what this static drawing can show us. In this animation, here is point F1. Imagine this is a push pin stuck into paper. This dot here is point F2, another push pin. And then this thing here is supposed to be a piece of string. Notice that the total length of the string is longer than a straight across distance from pin to pin. That gives it some flexibility that you can put a pencil in there and then pull it outwards to make the string tight. Now in the animation we can control a few of the parameters. We can move the focus points closer together or farther apart. We can control the total length of the string, making it longer or shorter. What do you predict will happen to the size of an ellipse if the string is longer versus if the string is shorter? Okay, let's clear away those marks that I made and now actually draw an ellipse. I'm going to click this point right here where the pencil is touching the paper and drag it. Here is an ellipse. As I'm drawing this ellipse, notice on the top of the screen where it's giving us the sum of distance S1 plus S2. That's this shorter distance here plus this distance here. They add up to 5.7. As I move the point, notice how it's still 5.7. Move it over here. The sum is still 5.7. And continue moving the point around. Notice how the sum is still 5.7. As one of the lengths gets shorter, the other one gets longer to compensate, and the sum is always 5.7. This leads us to a geometric definition of an ellipse in terms of distances. An ellipse is a shape created when two distances add together and always make a constant amount. Let's go back to the notes. Scrolling just a little bit, we see that definition of an ellipse. It is the set of points such that the sum of the distances from each point to two given points called foci is constant. In our drawing, it was F1 and F2, which were the names of our two focus points. A random point on the outside of the ellipse was point P, located at the tip of the pencil. The distance from P to F1 and the distance from P to F2 are called focal radii of point P. In our GeoGebra animation, those were the pieces of string. This distance right here is one focal radii, and this distance right here, which now is shorter than this one, is the other focal radii. Remember, as that point traveled around the ellipse, though, one of the focal radii got shorter while the other one got longer. When you add them together, it always equaled a constant amount. On a coordinate grid, if an ellipse is centered at the origin and the foci are at the points negative c, 0 and positive c, 0, as you see in this drawing. So imagine this dot right here is at the origin. It's labeled point C because it's the center of an ellipse. This green thing coming across here would be the x-axis, whereas a vertical line running downwards would be the y-axis. In this drawing, this focus point and this focus point are both on the x-axis. And the distance from the center over to the focus point is c units. That's why the coordinates are c, 0. And if the distance from the center going to the left to this dot is also c units, That's why the coordinates of that second focus point would be negative c comma 0. Let's go back up to where we were looking at the notes. The sum of the focal radii is 2a. Remember what focal radii is. It is the distance from a focus to whatever point you're looking at on the ellipse. So right now in this drawing, there is a dot shown up here. The distance from that dot to this focus is labeled A in our drawing. And because of how this is drawn right now, where that dot is perfectly straight above the center, if we connected it to the other focus point, that would also be length A. This length plus this length makes 2a. When you have this arrangement of an ellipse on a coordinate grid, this is the general form equation for that ellipse. Notice it involves squaring. X is squared and y is squared. Notice it has fractions. Notice there's a plus sign in the middle. And notice on the right side in standard form, it's equal to 1. Do you see the right triangle within the drawing right here? Because that's a right triangle, we know the Pythagorean theorem applies. And so we could find the distance from the center up to that top point by using the Pythagorean theorem. In the drawing, it's labeled B because this one was labeled C and this one was labeled A. Whenever we have an equation that has this basic format to it, then we know the shape will be an ellipse. Let's try an example. Sketch the graph of this equation. This has that format we were just looking at. I see x squared in this spot, y squared in this spot. I see fractions in both places. I see a plus sign, and I see equals 1. When it has all of those things, it is an ellipse. Now, in the general formula for an ellipse, the denominator of the x squared was a squared. So we can figure out what a is. It's 5. And in the general form for an ellipse, the denominator of the y squared term was labeled b squared. So what does b equal? It's a 4. With that information, we can draw the ellipse. Here's the meaning of getting a equals 5 when that's under the x squared spot. It means that one end of the ellipse is 5 units to the left of the center, and the other end of the ellipse is 5 units to the right of the center. Those are the x-intercepts. Here's the meaning of getting b equals 4 when that number is associated with the y term. It means the highest spot on the ellipse is 4 units above the center, and the lowest spot is 4 units below the center. Those are our y-intercepts. Now draw an ellipse. An ellipse is kind of a challenging shape to just freehand draw unless you're a great artist. It often has the tendency to turn out looking more like a football shape. But with practice, you'll get better at that. Going on, if an ellipse is centered at the origin of a coordinate plane, and the foci are located at 0, negative c and 0, positive c, then the ellipse will look like this. Because the foci are on the y-axis, the ellipse will be taller than it is wide. Look at the general formula. It has basically the same arrangement. It's got x squared, and there's a fraction, y squared and a fraction. It's got a plus sign, and it's got equals 1. And we can still figure out the value of b if we know values of a and c. Why is the b squared and the a squared switched when compared to the general form of the other one? Back up here. Notice how this is a squared under the x squared and the b squared's under the y squared. For the one that we're studying right now, we have the b squared under the x squared and the a squared under the y squared. That is switched because the letter a always is a larger number than b. And if the ellipse is going to be taller vertically than it is wide, then the number under the letter y has to be the larger number. Let's try an example. Let's sketch the graph of this. Even though the variables have squaring, this is not a parabola, because in a parabola only one of the variables is squared, the other letters by itself. We know two shapes that do have x squared and y squared. They are a circle and an ellipse. Well, which is it? Let's check to see if this is an ellipse. We know that the general form of an ellipse has a 1 in that spot. So let's divide everything by 100. 4 divided by 100 reduces to x squared over 25. And then we have y squared over 100, and that equals to 1. Is this a circle or an ellipse? Which one was it that had denominators under the x squared and the y squared? That's an ellipse. Now that we know it's an ellipse, which kind of an ellipse is it? The kind where it was longer horizontally than it is tall, or the kind that is taller than it is wide? Well, which of these is the larger number? The one under the x or the one under the y? Well, it's this one right here. So we have this second ellipse. In the general form for that, this number here is b squared. So we can find b equals 5. And this number here is a squared. So we can figure out that a equals 10. Now we can graph our ellipse. On the x-axis, go 5 units left of center and 5 units right of center. On the y-axis, go up 10 units and go down 10 units. Then draw in an ellipse to the best that you can. Here are some true or false questions to test if you're getting the main ideas. Is this going to be an ellipse? Does it fit the general form? This one's false because it has to have a plus sign in the middle. Next true or false question. Is this one a horizontal ellipse? That is the kind that's longer horizontal than it is tall. Yep, this is true because the larger denominator is associated with x. You're going to go farther out on the x-axis to get the intercepts than what you will on the y-axis. Next one, true or false? This one has x-intercepts at these two numbers and y-intercepts at these two numbers. This one's true because when you take the square root of 36, you get plus and minus 6. And when you do the square root of 64, you get plus and minus 8. Let's summarize the lesson. We looked at one more shape that can be defined in terms of distances. A couple days ago, we looked at a circle. Then yesterday, we looked at parabola. Now we have ellipse. In this lesson, we looked at the general form for an ellipse and discovered that an ellipse can be oriented horizontally or vertically. And it all depends upon which denominator is the larger number. Like on this very last one, because this one's larger and it goes with y, the ellipse will stretch taller than it is wide.